Now this is the second part of Euclid Book 2, proposition number 4. And we have just established that KBC is a right angle and BCG is a right angle. Okay, and their sum is 180 degrees. Now, the opposite angles of CGK, this angle right here, alright, and GKB, are also right angles. Why is this? Because GKB is an opposite angle to BCG, okay, and CGK is an opposite angle to KBC. So these two angles are opposite. And so therefore, they are also right. And we can prove this by Euclid Book 1, proposition number 34. This makes CGKB a square. And we can use a lot of similar reasoning if we were to go down here, and I'm not going to go through a whole mess of this, but if we go down here, HDFG is a square, okay? Just like this one up here is a square, so is this one, okay? Now, AHGC. Now, where is AHGC? Well, AHGC is right here, is equal to GFEK. GFEK. This rectangle here is equal in size to this rectangle here. We know this by Euclid Book 1, proposition number 43. Alright. Now, AHGC is the rectangle of AC and CB. Why is this? Because CG is equal in length to CB. So we could actually say that AHGC is actually the rectangle of AHCB. We could say that. Alright? Now, the sum of these two rectangles right here, AHGC and GFEK, is equal in size to the multiplication of, okay, if we were to take the area of AHBC, and remember this can also be B right here, this can be B, because CG equals CB, so this could actually be CB here. So, if we were to take the area of AHGC, or as we're calling it, AHBC, and multiply it by 2, we would get the area of these two parallelograms. Okay? Now, if we were to add HDFG, the area here, with CGKB, the area here, plus these two areas right here, which is AHGC and GFEK, we could then say that it would equal ACDF. Now, you say, well, where do we get ACDF? Well, if we change this letter to A and we change this letter to C, HG is equal in length to AC. Let's say that again. HG is equal in length to AC. So now, instead of calling this square HDFG, we're now going to call it ADFC. Okay? So the sum of ADFC plus the sum of CBGK plus twice AHBC, because remember we relabeled this, okay? So the sum of this, and twice of this equals all 4 of these areas. Whew. That's a lot to say. So, at this point, we have proven that the square of ADEB is equal to the quantity of the area of this, plus 2 of these. Long way to go about the whatever proof here, but that's the way it works. Alright, I will tell you more in a future video, so stay tuned.